The pump is made up of a number of components. There is a stationary kidney plate, so named because of the two kidney-shaped slots cut in it. The fluid supply from the reservoir enters the pump through one slot, and the pressurized fluid exits by the other. The cylinder block is rotated by whichever source is driving the pump. Cut into this block are a number of cylinders. There is direct metal-to-metal contact between the rotating cylinder block and the stationary kidney plate. This contact is lubricated by hydraulic fluid at system pressure. Each cylinder has a piston fitted into it. The pistons are connected by shoes to the non-rotating yoke or swash plate. Again, lubrication is by hydraulic fluid at system pressure. The angle of the swash plate, and thus the piston stroke, is varied by the position of the control piston. The control piston has pump outlet pressure on one side of it and a spring on the other. With the pump stationary, there will be no hydraulic pressure, so the spring will push the control piston fully to the right, and the swash plate angle will be maximum. The entire assembly is enclosed in a case which is filled with hydraulic fluid, cooling the pump, before it is returned to the reservoir by an independent pipeline. This oil is known as case drain fluid. The condition of the case drain filters are good indicators of the condition of the pump. As the pump starts to rotate, the pistons will ride up and down the angled swash plate, moving in and out of the cylinder block. They are moving out as they pass the inlet kidney-shaped slot, so they suck fluid in. As they move down the other side of the swash plate, they are now being pushed into the cylinder block, forcing fluid out through the pressure slot. As pressure builds up, the control piston will move to the left, reducing the swash plate angle, and therefore the pump output. When normal operating pressure is reached, if no surfaces are being operated, the swash plate will be almost vertical, the piston movement will be almost zero, and there will be only a small flow of fluid through the pump. This flow is for pump cooling and lubrication. It returns to the reservoir through the case drain return line. If a service is operated, the system pressure will fall. The spring will push the control piston to the right, increasing the swash plate angle and thus the piston stroke. Pump output will increase to maintain the pressure. When the service reaches its required position, output pressure will again rise, and the swash plate will return to its no-load position. On some pumps, a solenoid-operated depressurizing valve, offload valve, can be used to block delivery to the system and to offload the pump. System pressure is maintained and the pump output falls to below 1000 psi, allowing case drain oil to circulate, lubricating and cooling the pump. This valve is useful in the event of a leak in that part of the system supplied solely by its pump. The solenoid is energized to offload the pump, so in the event of solenoid failure, the pump will continue to operate.